Welcome to Cornerstone Home Inspector Education Center. Tonight we have water pressure, flow, and drainage testing for home inspectors. Tonight's presenter is going to be Stan Pajurski, 35, 36-year plus home inspector. And Scott Monafort, one of our owners, is here tonight too. He'll be chipping in, and as I will. If you have any questions during the webinar, feel free to unmute yourself and ask, or you use the chat bot, and Scott will be monitoring that, and I will be. And then when you're done talking, please just make sure you're muted all the time, because we don't want any background noise. I will hand it over to Stan.
Good evening, everybody. Thanks for attending. The Connecticut, well, first of all, go back to the first one, Jim.
Yep.
So we're going to talk about water pressure, flow, and drainage testing for home inspectors. It's a comprehensive training for licensed home inspectors on evaluating residential water system performance, safety, and within the industry standards. Connecticut requires that we tie in their standards of practice to everything that we present. So most of the states that are regulated are very similar to what we have. So we're just going to touch base on the Connecticut standards as far as the plumbing is concerned. So Connecticut requires inspectors to observe and report on interior water supply and distribution systems, including fixtures and faucets, interior drain, waste, and vent systems, including fixtures, hot water systems and related equipment, functional flow and drainage at representative number of fixtures. We are not required to determine sufficiency of supply for demand, inspect water quality, test shower pans, evaluate well systems or components, or inspect water treatment equipment beyond identification. Understanding the boundaries of any state standard or regulation ensures appropriate scope of service and protects against the liability from overstepping professional limitations. I know a lot of guys don't think that that happens a lot, but you still need to be very careful. So proper water pressure and flow are fundamental to plumbing system performance and occupant comfort. Issues in these areas can indicate serious underlying problems, from corroded piping to inadequate municipal supply. As inspectors, we must identify deficiencies that could lead to fixture damage, poor appliance performance, or costly repairs. Drainage problems can signal venting issues, blockages, or improper installation, all conditions that worsen over time and may present health hazards through sewer gas intrusion. So we're going to attempt to learn about pressure versus flow tonight, understanding the critical distinction between water pressure and flow rate and how each affects system performance. Testing methods, identify appropriate non-destructive testing techniques suitable for home inspections. Problem recognition, recognize visual and functional signs of restricted flow, pressure issues, or drainage problems, and clear reporting, report findings accurately within inspection standards while distinguishing observations from diagnosis. So we're going to start with water supply basics. Okay, Jim. So an overview of residential plumbing system. A typical residential plumbing system consists of two primary subsystems: the water supply system that delivers fresh water under pressure to fixtures and appliances, and the drainage systems that remove wastewater by gravity. These systems operate independently but must work in harmony for proper home function. The supply system includes a service line, the main shutoff valve, distribution piping, fixture connections, and protective devices like pressure regulators and backflow preventers. Understanding this infrastructure is essential for accurate inspection. So public versus private water supplies. When you're at a house, I mean, I think most of us know ahead of time if we're the house is on a well or public municipal water. But when the interns I trained may not have been so knowledgeable in the beginning. You know, the first giveaway is you find a meter in a house. If you don't find a meter in a house, it doesn't mean it's not public. you got to go outside and look for a meter box. But private wells, you're going to see probably a pressure tank. Maybe you'll see a jet pump, softener, stuff like that. So that's another giveaway. But public municipal water delivered through municipal infrastructure, pressure regulated by water utility, typically 60 to 80 psi at the street. The quality monitored by local authority, may require pressure regulator valve if pressure exceeds 80 psi. Most common in urban and suburban areas. The home inspector's focus is on the service connection and in-home distribution. With private well systems, pressure is created by a well pump and tank. The tank pressure switch controls on and off cycle. The typical range is 40 to 60 psi. Pressure drops as water is used. Recovery depends on pump capacity and well yield. Common in rural areas, inspectors should observe pump cycling, pressure tank condition, and flow consistency.
Just want to jump in for a second, Stan. Quality monitored by local authority. I know, when we do these webinars, we like to have it from the aspect and the perspective of a home inspector. And so we're always telling stories. I don't know how many of you get the request on when you have public water, but we do get requests to have the water tested. How I handle it is I inform the client that they're more than able to call the local town, and the town has to give them a water report for the water quality. But I will still have people want to do it. Our local lab, Aquatech, they test for public water also. So it's something, that you may run across. But I do take that business too. So go ahead, Stan. Sorry.
So how water pressure is created and regulated. So the source is a municipal system or well generates initial pressure. The regulation, if needed, I'm going to say maybe 10% of the houses that I inspect will have a regulating valve, and that's intended to reduce the excessive street pressure to a safe working level. Distribution in both cases would be pipe network delivering water throughout the home, and the fixtures and appliances receive the generated pressure or generated and regulated pressure for operation. Pressure naturally decreases due to friction loss and piping, elevation changes, simultaneous fixture use. So understanding this helps inspectors identify abnormal conditions.
Steve, in your reports, if you don't see a regulator valve, do you call that out, or is that something that you're just normally not calling out on?
If I feel the pressure is too high in a house and there's no regulator valve, I will recommend them having a plumber come out. Look, if I turn on a faucet and water caroms out of the sink, to me that's too high. I don't put a gauge on anything anymore. I used to when I first started. I just go by what I see in the house now. If there's a trickle, we're going to get to all that. So no, to answer your question, unless I feel the pressure is elevated, I don't mention that there's no regulating valve.
Okay, all right.
So key system components, the main shut-off valve, obviously we're going to tell everybody how to shut their water off. Sometimes we got to look around to find it, but we should be making that effort to find it. It controls the main water supply entering the home, typically located near the water meter or where the service line enters the foundation. Must be accessible and fully functional. And as I said before, if you don't find one in the house, you may want to look around outside, because occasionally we'll find them outside in the meter box. Pressure regulator reduces high incoming water pressure to safe household levels, usually between 50 and 60 psi. This bell-shaped device is typically installed after the main shutoff valve. Regulator testing and adjustment or replacement are crucial for proper function. Distribution piping, the network of supply lines responsible for delivering water to all fixtures throughout the home. Common materials include copper, PEX, CPVC, or older galvanized steel. The condition and materials of these pipes significantly affect most or both water pressure and flow. expansion tank designed to absorb pressure fluctuations caused by thermal expansion, especially in closed water systems or those with a PRV. It is typically located near a water heater and must be properly charged and functional to prevent damage and maintain system stability.
But you don't test main water shutoffs, right?
No,
Right. And you tell your trainees and your interns not to touch them.
correct. They
Okay.
can do whatever they want to do when they're finished with me, if they want to be superheroes. But and I explained to them exactly why.
Yeah.
But everybody after they get trained, they don't want to be a little Jim or a little Stanley. They want to establish themselves. So who knows what they do?
Right.
How
Okay.
about you,
I mean,
Scott?
in my years, I probably have done it 2 or 3 times, but that's either with verbal permission from the homeowner or checking with someone in charge that can make that decision. But then I tell them, I'm like, there's no guarantee what happens, and it's just going to go for that. But I agree with you. It's a hard no. When something's off, it's off for a reason, and it's a pretty good reason normally. So.
The first guy I ever took on as an intern, we looked under a kitchen sink and there was a chrome plated brass trap, and it was really, really corroded. And I told him, like, when you see these, don't touch them. Just call them out. And I walked away after we finished the plumbing, and he touched it, and it fell apart.
Yeah.
And yeah, it just crumbled. And he learned on my dime at that point. But not a big deal. But those are the reasons why you don't get too crazy, because in some cases you could take your check and turn it over to the homeowner.
And Stan,
So,
just to go over again, because we have a bunch of new members again tonight. Some of the stuff that we cover, gentlemen and ladies, it's kind of obvious. But if you're in the industry less than a year, it's good hearing these stories from somebody like Stan, who's got 37 plus years in the business. And just to reaffirm what you've been taught, and possibly if you've been taught something else, you get a different opinion from somebody who's been doing it a real long time. So, all right.
yeah, we're not here to make you do things like we
Us, right.
do. I think we're here just to give you some options. Like, for instance, I've done this for 37 years. The first 2 years I used gauges. I would record water pressure. I stopped 35 years ago, and I'm not getting calls every other week. How come there's no numbers in my report? How much was the water pressure? To me, it's either it's functional, it's low, or it's too high.
All right. We have our viewing code. If you're watching this as a pre-recorded event, your viewing code is WP7346.
So typical household pressure ranges. The optimal range is 50 to 70 pounds. I think 70 is a little high, but that provides excellent fixture performance and protects plumbing components. 40 to 50 is acceptable. PSI is functional, but may result in weaker flow at upper level fixtures. And then maximum safe pressure, 80 PSI is the code limit. Higher pressure stress fixtures and connections. That's when the water caroms out of the sink. I always operate all the fixtures on the highest level together to see how much of a pressure drop, what the head pressure is up there. So I just base all my feelings on what I'm saying, basically. Most plumbing codes specify that static water pressure should not exceed 80 psi. Pressures above this threshold require a functioning pressure reducing valve to protect the system. And that's coming up, a better explanation of that. So problems associated with low pressure. So number one, of course, poor fixture flow, weak shower streams, slow filling toilets, inadequate sprinkler coverage. So if you have one fixture that's low, it could be the aerator, it could be a valve, it could be the fixture itself. If all the fixtures are low in a house, then we probably have some kind of water flow problem. Extended fill times, washing machine and dishwashers take longer to operate. Pressure drops significantly when 2 or more fixtures run simultaneously. Second floor fixtures perform worse due to elevation pressure loss. So I had a house the other day that was a pretty significant pressure drop when you operated several fixtures together. I don't care where they were. And these people wanted that house so bad, especially around here with the low inventory, that I don't think they were taking my warning properly. So I made sure in the report that I covered myself and, you know, made it a significant concern that needs to be followed up. The market's such now that people lose a lot of bids, and when they get in a house, they don't want to pay attention. Now, I'm not saying that if they did have an issue that they recognize later that they're going to come and give you a hard time, but we want to kind of eliminate that. Take it a step further in the report as well to make sure that what you said at the house is reinforced. Problems associated with high pressure. Excessive water pressure above 80 psi creates substantial stress on plumbing systems and can dramatically shorten component lifespans. High pressure forces water through seals, gaskets, and connection points with excessive force. So pipe stress and leaks, the joints, the fittings, the threaded connections experience accelerated wear. Pinhole leaks may develop in copper piping, particularly at elbows and T's. Appliance damage, so water heaters, washing machines, dishwashers, ice makers, they all contain solenoid valves and not all, I'm sorry, and internal components not designed for the high pressure, so premature failure is common. Fixture problems. Toilet fill valves run continuously. Faucets drip and spray attachments leak at connections. Cartridges and seal wear rapidly. And then water hammering. High velocity water creates hydraulic shock when fixtures close suddenly, causing loud banging and vibration that can damage piping and support. So you will, if you're new, you'll start to develop a knack of picking up on these things as you walk through the house. And the old timers see this almost immediately as an issue. They just want to see how much is out there collectively in the plumbing system before they make their final assessment. Evaluating water pressure, testing methods and identification of pressure-related deficiencies. Static pressure is the water pressure measured when no fixtures are running. The system is at rest. This represents the maximum available pressure in the system and is the most consistent measurement for documentation. Static pressure is measured using a pressure gauge attached to a hose bib, exterior faucet, or other convenient test points. The gauge provides an immediate PSI reading. This simple test takes only moments, but provides critical information about system pressure. Measurement best practices ensure all fixtures are off before testing. Test at a ground level exterior faucet when possible. Allow pressure to stabilize for accurate reading. Document the reading and test location. So if you use gauges, those are the recommendations for best practice. Do we need to use a gauge to determine adequate water pressure? Yes, if you want to or must determine the exact number pressure reading. No, if you are comfortable with judging the pressure flow from the fixtures in the home. That's me.
That's also very important too, because when a client's following you around, I've had couples with me standing watching flow, and the wife will be like, yeah, time to go, next room. And the husband will go, how come you're not talking about how that water's pouring out of the shower so slowly? And the wife and I are looking at it and like, that's good pressure. So that's a subjective thing. Some people like it more, some people like it less. It's a judgment call. If it's ridiculously low after a certain number of homes, you're going to know that, you know. But if the husband complains, I put it in the report, and that this way they have an outlet with the agent to address it if needed.
Sometimes before we even start the inspection, they'll say, hey, you know, we're a little concerned about the water pressure. The shower didn't look good. I know some people will take the shower head off and see what the pressure is like without the head on. I'm not getting into that.
Yeah.
But you know, it could be the shower head itself. So you got to look at all the rest of the fixtures in the house. So functional flow, real world observation. While static pressure provides a baseline measurement, functional flow reveals how the system performs under actual use conditions. This qualitative assessment involves operating fixtures individually and in combination to observe pressure maintenance and flow characteristics. So we can't 100% duplicate how a house is used, but we can do that recommendation. You want to be able to operate multiple fixtures at one time and on each floor when they're available, to see how that changes as we go up to the next level. So operate each fixture independently and observe flow strength, consistency, and any unusual sounds or behaviors. Run multiple fixtures at once, shower plus flush the toilet, kitchen sink plus washing machine to assess pressure drop. Compare flow between first and second floor fixtures to identify pressure loss from elevated changes. If you have a little bit lower pressure on the second floor, I'm going to say that's to be expected. If you have great pressure on the second floor, you probably have a little bit high pressure on the first floor. So you got to find that happy medium. Functional flow testing provides context that static pressure alone cannot reveal. A system may show adequate static pressure but perform poorly under load during due to undersized piping or flow restrictions.
And also, not sorry to interrupt, for newer inspectors, simultaneous testing. Don't be in the second floor and you're going to fill up a jet tub, or you're going to run water in a sink, and you're going to run around, and it's a 8,000 square foot house, and you're going to turn on everything. You really don't want to leave water unattended, because the sinks can clog, tubs can overfill, and then you forget what's open and you're down in the basement taking a shower from something on the second floor. I know if I'm letting the kitchen sink run, the agents are usually there. I'll have an agent stand there and just say, listen, you're on your phone, glance at the water every minute or two, make sure, every once in a while, make sure nothing's causing an issue. And just try not to leave your water unattended for too long, because I can tell you from experience, it's not going to go well.
Except for the first 2 years of my career, I've always been a member of an organization. At first, CAHI, ASHI, and then the Connecticut Association of Home Inspectors, and now even us. And it's much better to learn from other people's mistakes, hearing their stories, than to make them yourself. But occasionally we do make a mistake. So this was a while ago, I turned on the dishwasher in a condo and walked away. And when I came back in the kitchen, the floor was sopping wet because the seal on the dishwasher was leaking. Now, luckily, it was a small kitchen and the floor was sheet good, so it didn't get to the unit below, and we cleaned it up. But everybody walked out of the room, even the realtor. We came back in and like, holy cow. But so you learn. So I've never done that again. If you didn't learn from your mistake, then
you're going to make it again.
Water flow. Different valves have different water flow rates due to factors like internal design, port size, and the valve's primary function. Valves restrict flow to varying degrees, with some, like full port ball valves, allowing nearly the full flow of the pipe, while others, such as globe valves, create more resistance and a significant pressure drop. The type of valves and its specific model and size are keys determinants of how much flow it will allow. So a full port ball valve are designed to have a larger internal passage and create little or no restriction, allowing for maximum water flow. Globe and multi-turn valves, these can restrict flow more significantly. In a globe valve, the fluid must change direction, creating more resistance and a higher pressure drop. Check valves are designed to prevent backflow and may have a minor impact on flow during friction, but the restriction is usually minimal. And needle and pinch valves, these are often used for precise flow control and can be adjusted to allow specific controlled amounts of flow. Valve size and quantity, a larger port size will allow more flow, and cheaper valves may have smaller ports, even if they are smaller type and more expensive, higher quality valves. So the
In the
valves,
next, yeah, the
they
next
have
couple
a
of
big
slides, we have
impact.
some pictures.
What's that, Jim?
The next couple of slides, we have some pictures and examples. So that's our full
So this
port
is
ball.
your full port ball valve. So it
You can see the-
almost 100%.
So that's,
flowing.
you see how it's off and it's blocking, and then there's your opening.
It's always good to see a cutaway version of anything, really. So globe valve, you can actually adjust. You can restrict the water flow by how far down you turn that valve or how high up. But they're more problematic in operation. They can fail in the closed position or the on position. Ball valves are much more reliable. We're not doing a valve thing here, though. We're doing a water pressure.
Well,
and
let's see. Here's a check valve.
So a check valve, I don't have the pointer, but inside that, they can get gummed up too, so you can take that apart and clean it up.
Yep. And then here's a pinch valve example.
Yeah, that's more commercial.
Yep. I just thought you'd like to see the pictures. There we go. Next slide.
So when and where to test during inspection. Optimal testing sequence. Measure static pressure early in the inspection at exterior hose bib. Test kitchen fixtures during kitchen inspection. Evaluate all bathroom fixtures room by room. Check laundry connections and observe washing machine hookups. Perform simultaneous use test with accessible fixtures. Strategic test locations, exterior hose bibs for the best static pressure gauge reading, master bedroom shower and the highest household demand fixture, kitchen sink, central location with good visibility, second floor bath, test elevation, pressure loss, and basement fixtures may reveal supply line issues. Okay, Jim? So signs of pressure problems. Weak shower stream. Shower head should produce strong, consistent flow. Weak or sputtering streams indicate low pressure. Clogged fixture or restricted supply lines. Test with shower head. Remove to rule out fixture blockage. If you have any fixture that you think is got a pressure problem or a flow problem, and you have the ability to look at the line that's supplying it, sometimes they're bent and they get kinked instead of having an elbow, a sweated elbow. They could have been damaged just by dropping something against the pipe in the basement. So it's something you can do if you do it easy and don't spend a lot of time, or you can just call out the fact that the pressure seems to be off a little bit and have it further evaluated. Pulsing water flow. Rhythmic surging or pulsing suggests pressure regulator failure. Waterlogged pressure tank, I've seen that, or pressure partially blocked supply. Flow should be smooth and continuous. Water hammer, loud banging when fixtures close rapidly, indicates high water velocity from excessive pressure or missing failed water hammer arresters. Common with quick closing solenoid valves. And inconsistent pressure that varies significantly between fixtures or over time may indicate municipal supply fluctuations, well pump issues, or internal distribution problems requiring investigation. Anything out of the ordinary, we should be questioning and reporting on. So understanding pressure reducing valves. Pressure reducing valves are essential protective devices that reduce the incoming water pressure to safe household levels. They're required when street pressure exceeds 80 psi, as we said before, and are commonly found in homes with municipal water services. Their location, they're typically installed on the main supply immediately after the shutoff valve, often in basements or crawl spaces. They're a bell-shaped body with adjustment bolt on top. They're a little different now. We have pictures of the new ones. Adjustment can be tuned to desired pressure, usually 50 to 60 psi. Lifespan is 10 to 15 years under normal conditions. Failure modes, they may stick open, so that would result in high pressure, or partially closed low pressure. Inspectors should verify PRV presence when static pressure testing indicates high pressure and notes its condition and accessibility.
Question. So
Yeah.
you can leave it on the slide. That nut on the top of those is an adjustable feature?
Yes. Right here?
Yeah,
Okay, so they're not factory set. So if somebody's having less pressure than they want,
so one of the problems with those
call
is
plumber.
you could jack those things wide open. You know what I mean? The homeowner can do that. If you go to the next slide, Tim. So even the new model, which is the same as the other one, but they just have different material on top. You adjust those. I mean, technically, there's supposed to be a gauge on that, so you can look at the pressure you're setting it at. And you want to be in that 40 to 60 pound range. But that doesn't prevent the homeowner from wanting a more force out of a shower and opening that thing wide. So I don't really even mention how to change it when I show people. You know, if the
Right.
water pressure is good in the house, I'm not going to tell them, if you want a better shower, just jack this thing up. But, and they do fail. But
The life
every
cycle
time
on
that I've seen one of these, they were accompanied by a gauge.
They're saying the life cycle on these are about 10 to 12 years. And here's we go.
All right,
Adjustable
so the
screw.
screw,
Yep.
the spring, the diaphragm, some have a strainer, not all of them, and the seat at the bottom. So the spring pressure opens up, pushes down, and lets the water through.
And this is where you're going to get your the 10 to 12 year lifespan, because these things clog up. That's
And just another version
another,
of
yeah, I put this
Cutaway.
in there.
Cartoon version.
Yep.
So expansion tanks at water heaters. Now, did Scott leave?
Yeah, he's not able to talk though. He's on the road, I think.
Oh, okay. So thermal expansion tanks are required in closed plumbing systems. Those with pressure reducing valves or backflow preventers that prevent water from flowing backwards towards the street. So around here, in Connecticut, at least where I've been, I might see an expansion tank on a new installation or a new construction, but I don't see very many of them yet. I don't know how that is anyplace else. I don't call it out. I don't even know if it's code in every municipality. And I'm just going to compare that to the acid neutralizers for condensing style heating systems and water heaters. Technically, in new construction, you're supposed to have the condensate lines piped through an acid tank or filter. And there's new construction in my hometown that uses gas and the condensing style appliances that they're not being put in. I recommend that they put them in, the neutralizers, but so I kind of stay away from the code. But anyways, just to get back to this, so in a closed system, the expansion creates dangerous pressures, pressure increase that can reach 150 psi or higher, potentially damaging fixtures and the water heater itself. Visual inspection, ensure the tank is properly supported and its connections are free of corrosion or leaks. Check the bottom of the tank for any signs of rust or deterioration. I think you want to look at this very much like a boiler's expansion tank, basically doing a similar job. Tap the tank with your knuckles near the top and bottom. A healthy tank should sound hollow at the top and solid at the bottom. A tank that's fully waterlogged will sound solid throughout and need replacement. Right. If a pressure reducing valve is present, the expansion tank is crucial. Its absence can lead to relief valve discharge, damage to plumbing fixtures, or premature water heater failure. Recommend installation where missing. So I don't do that because I don't see them often enough to be able to say that you really should have one here. But just in case, and if that's the same in your area and you come across one, at least you got an idea why it's on the system. And this is saying where you have to have a pressure reducing valve or backflow preventers. I'm seeing them on water heaters in, just regular straight city water without a regulator.
Right.
So, but
You
occasionally.
You also see these expansion tanks installed sideways. I used to call it out because it didn't make me too happy knowing that there's a bladder in there and it's set on a side position, on a horizontal position. But I've had many techs tell me, my own guys who service my equipment, and mine's sideways, and I tell them, why'd you install it that way? And they go, you can install it. The manufacturer says they're able to be installed sideways. So if you see it sideways, it's not necessarily a defect. I don't like it sideways because if it becomes filled with water, it can sink and bend and damage the threads, and you can get water leaking. But that goes to make sure it's properly supported. So if it does fill with water, it's not going to do that, but you don't see it supported correctly all the time. So that's when I'll call it out. If it's sideways, not supported correctly, I'll put in my report, get additional support in there for the tank in case it does fill with water, because we don't want to damage those threads.
Evaluating water flow. Distinguishing flow from pressure and identifying restrictions.
Sorry.
Okay, Jim. Pressure versus flow, the critical distinction. Pounds per square inch is pressure, the force pushing the water through the pipes. Measured with a pressure gauge, relatively static when no water flows. How hard is the water being pushed? Example, 60 psi static pressure. So that could be straight from the street, pushing the water into your house. And who knows how far that 60 pounds will last. Gallons per minute is the volume of water delivered over time, measured by collecting water in a container, dynamic changes as fixtures operate, how much water is being delivered, example, 2.5 gallons per minute shower flow. A lot of houses around here newer houses have the restricted flow valves anyways, they're required. A system can have excellent pressure but poor flow due to restrictions. Conversely, high flow is impossible without adequate pressure. Both parameters must be evaluated to assess the system performance. So we've kind of discussed this a bit. The most practical flow test during a home inspection involves simultaneous fixture operation. This reveals the system's ability to maintain adequate flow under realistic use conditions, such as a shower running, when a toilet flushes, or multiple bathrooms are in use at once. So baseline flow, observe the flow at a single fixture, note stream strength and consistency, activate additional fixtures if accessible, assess cumulative effect on the flow, add a second fixture while the first continues, activate second fixture, observe pressure drop, document response. Note degree of flow reduction, several drops suggest undersized piping or restriction. This is kind of important in a multifamily home. So if we have a 3-family and you have no idea how many fixtures are going to be used at one time when everybody's home. So I'm sure in a 3-family home, water pressure is all over the place, depending on how many people are using it at one time. That's something that we're not going to be able to predict. You may be able to do these types of tests in each apartment, but I don't run from floor to floor and try and put 3 groups of fixtures on. So I put a note in my report, basically, that that water pressure is subject to change based on how many people in that house are using water at one time. Visual clues for flow restriction. Experienced inspectors will recognize visual indicators that suggest flow restrictions before testing fixtures. These observations, combined with functional testing, provide strong evidence of system limitations. Galvanized steel piping. First of all, if you see any galvanized piping in the water supply, you need to write that it needs to be replaced. You have no idea what condition it's in. It's got to go. They develop scale on the inside, as you can see in this picture, and they severely restrict flow. And I do that even for waistline, galvanized waistline. A 3/4 inch pipe may only have a 1/4 inch effective diameter after decades of use. Sediment and aerators. Remove faucet aerators to check for rusted particles, scales, or debris, evidence of corroded supply lines or water heater sediment. My advice to you, unless you have a bunch of aerators on your truck or car, don't touch them, just note it. You might be able to look up at them, flash your light there, see if they look clogged or in bad shape. But you damage one, take one off, can't get it back on, you're going to Home Depot.
Yep.
Undersized supply lines. Fixture supplies smaller than 1/2 inch or main supply lines under 3/4. Limit flow capacity, especially during simultaneous use. The other day I had the one where the water pressure was fluctuating and the people wanted the house real bad. That was a 1/2 inch supply. I knew going upstairs we were going to see something. They're still out there, the 1/2 inch supply. Effective piping materials on flow. Copper is smooth interior, maintains consistent flow, minimal friction loss, type M wall thickness, adequate for residential, expected 50 years plus service life, and may develop pinhole leaks and corrosive water. PEX, cross-linked polyethylene, modern material with excellent flow characteristics, flexible installation, reduces fittings, immune to corrosion and scale buildup, the pipe, and slightly higher friction than copper, but negligible. Expected 50 years service life on the pipe. The fittings might be another story. CPVC, acceptable flow in properly sized installations. Rigid system requires more fittings, becomes brittle with age, especially in hot water. Connection failures more common than leaks. Variable longevity, 25 to 40 years, typical. So I explain to people, I don't see it a lot around here, but if the supply lines are CPVC, I suggest to people that they consider replacing them at some point in time. Galvanized steel, once common, should be flagged, as I said, as a flow restriction concern in any home over 30 years old. Replacement is often necessary during ownership. Intermittent flow and pressure drop. Intermittent or fluctuating water flow presents a diagnostic challenge. Unlike consistent low pressure or restricted flow, these issues come and go, making them difficult to operate during inspection, but frustrating for occupants. So a lot of that is well system issues. If you're in a house with a well, cycling pressure as pump turns on and off, waterlogged pressure tank, failing pump check valves, or inadequate well recovery rate. Pressure varies as tank depletes. Municipal supply fluctuations. Peak demand time, morning, evening, can cause temporary pressure drops. Water main, we may not as home inspectors see that fluctuation from morning to evening. Water main, unless you do a 12-hour inspection. Water main work or system issues in a neighborhood affect multiple homes. Partial valve closure. Main shutoff or intermediate valves may not be fully open and they may restrict flow. Valves may be difficult to see or access. Even a 1/4 turn from fully open significantly reduces flow. So somebody could have been in the basement and just shut off a valve and never opened it all the way back up again completely. And then failing PRV, pressure reducing valves can stick intermittently or develop internal debris causing inconsistent regulations, may require cleaning or replacement. And sometimes even the fixtures, some of the older ones that still have seals or washers in them, the washers will flutter and don't make a noise and affect the flow of the water. This frequent question requires a measured professional response. What clients perceive as pressure problems may actually be flow restrictions, fixture limitations, or simply different from their previous residence. Professional response framework. Measure and document. Static pressure measurement 58 psi, which is within normal range. Explain the functional test. Flow at fixtures appeared adequate for typical household use. Identify actual issues. However, corroded galvanized pipe observed in the basement likely restricts flow to this fixture or group of fixtures. Recommend action. Consider plumber evaluation for piping replacement to improve flow, and set expectations. Functional pressure, but system age suggests future improvements may be desired. When I moved in my house, we had a half-inch supply line. Water pressure was low as well because we were off a gravity tank, and I had everything updated as far as we could go to 3/4 inch, and it made the house functional. We don't have any problems now. So it increased the volume of water, not the pressure. Distinguish between inadequate pressure requiring immediate attention and adequate but improvable systems where upgrades are optional. So this is a debatable, Jim and I were talking about this earlier today. This is a bit of a debatable topic. What is a yield, a well yield test? When I first got into business, they called it a well yield and recovery test. And most of the guys around here were opening the well, dumping the water right on the surface, and measuring the gallons per minute output. And they had a static wire going down. They'd run the water for an hour and then measure how fast it filled back up if they didn't run out of water within that hour. So I'm going to read now what they do today. So a yield test consists of determining the balance between the maximum amount of water that can be pumped and the amount of recharge back into the well from the surrounding groundwater. Testing is done by continuously pumping water from the well for an extended period. During pumping, measurements are made of the amount of water flowing from the well, and the amount of water level is lowered in the well. This is known as the well's drawdown. And the static level is where it starts. It's never filled up to the top. So they used to open the well to see where they're starting at to get a more accurate level. Equilibrium is achieved when the drawdown remains stable for a given discharge rate. Once equilibrium is achieved, less pumping should result in lower drawdown rates. Professionals rely on this pump yield test to place the well pump at the correct depth in the borehole. The standard is to maintain a water level of 25 feet above the top of the submersible pump. This allows for a comfortable margin of safety during drought conditions and works to keep the pump motor cool and running properly during use. Water pressure in your home is not entirely dependent upon overall yield. Proper sizing of the pump, pressure tank, and lines can increase water pressure even in instances of lower yield. Okay, Jim. A well yield test determines the amount of water a well can consistently supply. When conducting this test, specific steps ensure accurate measurement, especially for existing systems. But it's also kind of important to know how fast that well recovers, in my opinion, because if you're pulling all the water out and it's not keeping up, at some point they can run out of water during drought. So it's good to know ahead of time. Usually there's some indicators, but I think knowing how fast it fills back up is kind of a good thing too. For best results, water should be taken directly from the pressure tank whenever possible. So that's not what they used to do when I first came out of the cave back in those days. Water is run from the well in 5-gallon increments. The flow rate from the last 5-gallon interval is determined to be the well flow or yield for that well. And that's what most guys are doing now. Because water runs through the bottlenecks of the well pump and pressure tank, the flow rate of 10 to 12 gallons per minute is usually considered an excellent result for this test. This number may differ from the well yield results produced at the time of drilling, as the bottleneck would have been eliminated in those measurements. So procedures for existing wells. Provide a testing manifold. The contractor performing the test must provide a testing manifold. The manifold should include an inlet for connecting to the pressure line from the well and a T with a pressure gauge. The gauge must be graduated in intervals of at least 2 pounds per square inch PSI and capable of measuring up to 200 PSI. Bypass the pump switch. The testing manifold must be connected in such a way that the pumping switch mechanism is bypassed. Record initial data. Turn the pump on and open the manifold valve completely. Time, the flow rate, and pressure readings must be recorded. Time, flow rate, and pressure recordings must be recorded every 15 minutes. Determine the recovery rate. If the water level is drawn down to the pump intake, turn the pump off and record the time. Wait a set period of time, for example, 15 minutes. Turn the pump back on and measure the discharge of water until the water level is drawn down to the pump intake again. Record the time. Repeat this process at least 3 times to determine the well's recovery rate. The well yield is determined by dividing the average discharge in gallons by the average interval in minutes between each time the pump was shut off. So I don't know if every home inspector wants to get into this.
No. So we've got about 10 minutes left, but I do want to comment on this. When most of us are going to show up with the equipment to measure gallons per minute and the pressure of the well. We're going to hook a hose up. I was taught, get permission from the seller before you do a flow test, because you can drain a well and then they run out of water, and then who's responsible for that? So I was taught, you show up, you get permission, you hook your hose up, you stand there for you check your pressure, and then you hook up your flow meter. You run the water for a minute, standing there checking it, write down those numbers, and then come back every 15 minutes. I got to tell you, I stopped doing that like 10 years ago. It just was. I've had too many well people who have showed up after I've done that and tell me that flow test is just really not reliable. It's not a good test. I try to figure out prior to the inspection how crazy my clients are going to be about the well. If they're not mentioning it when they're asking me to do the home inspection, I know what to do. I know what flow to use. I know what to look for. And if I see a well that's deteriorated and rusty and the equipment inside, we're going to make a recommendation for a well water specialist to come out. I don't take off those caps. I think you're just buying yourself headaches. I know inspectors who do, but it's something that, and the other thing too on report writing for this, you have to remember that these tests are just a picture in time. It's just a moment in time, because 2 months later you could be in a drought and those people are going to run out of water, even with the best flow tests and the best pressure. And the water runs dry. And I've had it happen to me six months later after I do an inspection. A client calls me up and well went dry. You said everything was fine. There you go. All right, Stan. So
I agree. And I think with a system like this and a septic, you just pass that on to the experts and let them take the heat, basically. Yeah. If the people even want to go that far, to be honest with you. So recovery rates of 4 gallons per minute or greater, testing may be terminated after 3 hours if the water level is determined to have dropped no greater than 200 feet through the duration of the test, or the discharge pressure does not vary by more than 5 psi. For well yields less than 4 gallons per minute, the yield test shall continue by valving down the discharge to the approximate well yield determined in step 4 and recording the flow rate and pressure every 15 minutes for 1 hour. So you're going to be there longer than you would be there for a home inspection if you do it this way.
The way it's supposed to be done, right?
Yeah. Drainage and waste testing. So drainage system evaluation is as critical as supply system assessment. While supply problems cause inconvenience, drainage failures create health hazards, property damage, and expensive repairs. Home inspectors must verify that wastewater flows freely from fixtures to the building sewer line. Unlike pressurized systems, supply systems drainage operates by gravity. Water must fall through the pipes with adequate slope, typically 1/4 inch per foot, while air enters through vents to prevent siphoning and allow smooth flow. Testing reveals blockage, improper slope, venting deficiencies, and trap problems. So everything we do is supposed to be visual, but observe accessible drain piping for proper slope, support, and connection integrity before running the water. Activate the fixture, run water for full flow for 30 to 60 seconds to observe drainage performance and test system capacity. Monitor drainage speed. Water should drain completely within seconds after shutoff. Note any slow drainage or standing water. Listen for sounds, gurgling, bubbling, sucking sounds indicate venting problems or partial blockage downstream. Operate fixtures on different branch lines at different levels to identify systematic versus isolated issues. That's very important. And know which fixtures drain slowly, exhibit unusual sounds, or show signs of previous backup. Identify slow drains and partial backup. Slow drains result from restrictions in the drain line, trap, or vent system. The issues may be localized to a single fixture or affect multiple fixtures sharing a branch line. Hair and soap buildup in bathroom sinks and drain and tub drains, particularly trap areas. Grease accumulation in kitchens. Foreign objects, toys, jewelry, dental floss create partial blockages. Root intrusion. Older sewer lines may have tree root penetration. Inadequate slope, improperly installed piping doesn't allow gravity flow, and vent blockage. Plugged vents prevent air entry and slow drainage. Individual fixture problems often indicate localized blockage, while multiple slow drains suggest mainline restrictions or venting. One thing, if I walk in a basement or any place in the house and I see Bob's Drain Cleaning Company sticker there someplace, they had a sewer line problem. If you see a new compression cap on the drain on the sewer line clean out, they had something going on there. I write that up. I take a picture of that, and I tell them that they should at least question the owner as to why Bob was there.
Your viewing code, if you're watching this as a pre-recorded event, is WW0286.
Visualizing plumbing vent problems. Drain, waste, vent systems require proper venting to function correctly. Vents allow air to enter the drainage system, preventing vacuum formation that slows or stops drainage and can siphon water from traps. Venting problems are common in older homes and amateur plumbing work. So gurgling sounds in drains are distinctive sounds when fixtures drain, points to air being pulled through the trap water, primarily system of insufficient vent flow. Persistently slow drainage, water that drains sluggishly despite clear pipes, suggests that air cannot properly enter the drain system to equalize pressure, hindering efficiency. And then siphoning of water traps. A vacuum can pull water directly from P-traps, compromising the water seal and allowing foul sewer gases to enter. You know, if you look at that picture right there, that's an S-trap. It doesn't mean that they're always going to be siphoned out, but that's one of the problems with an S-trap, that if the water flows through that fast enough, it's going to suck all that water right out, and you'll smell the sewer gas odor, and the closer you get to a sink, you'll smell it stronger. So is somebody going to remodel their whole kitchen to make that a P-trap? Because it's sometimes difficult. So you just tell them that this is an old style trap. It could smell. You add a little bit of water in if you determine that it's stronger at the sink. And then if you ever remodel the kitchen, you have an opportunity to change that to a more modern fixture. So again, S-traps are prohibited by modern code, but they're still out there, at least in this area here. Flat traps without adequate depth or improperly aligned, fail to maintain consistent water seal. You look under flips, remodeled homes, sometimes the sink isn't in the exact location where it was before, and you see some of these masterpieces that they put together underneath those sinks just to get it to drain. You know, half of them aren't conventional, but what alternative do you have? So if you don't think they're siphoning, you don't smell anything, they're functional, but I would make a note that this isn't the typical way that you would pipe a drain line, and even carry a picture that shows them the best way to handle things. Double trapping, 2 traps in series on a single fixture drain, often accidental during remodeling, creates airlock between traps, causing extremely slow drainage or complete blockage. So modern P-traps with proper venting are the standard. When deficient traps are observed, recommend licensed plumber evaluation and correction. So again, outdated X-trap, siphon hazards, and the modern P-trap. So critical safety points: never operate fixtures if standing water is present. Indicates existing blockage that could worsen. Avoid overfilling during tests, could cause overflow and property damage. Don't test if backup signs visible, staining around the drains, or clean out access. Monitor continuously during operation. Be ready to stop water flow immediately. Do not walk away from a running fixture. Limit test duration to 30 to 60 seconds, sufficient for most fixtures. Do not use chemical drain cleaners. Do not attempt to clear blockages. Do not remove or disassemble traps. Do not operate fixtures against occupants' wishes. Do not test fixtures disconnected from drainage. I think we all are smart enough to know all that. Your role is to observe and document, not diagnose or repair. When drainage problems are evident, recommend appropriate professional evaluation. Sewer gas odors and drain seals. Mixture of hydrogen sulfide, methane, or other compounds pose both health risks and indicate drainage system deficiencies. The distinctive rotten egg smell should prompt immediate investigation of trap seals and venting. You'll get to know that smell. You'll run across it occasionally. Dried out traps will smell. You know, house has been vacant for a while. Nobody's putting water back in the traps. Lost trap seals, damaged wax rings, broken vent pipes. All these things will contribute to the odor in the house. I know a lot of guys do their own shoreline evaluations, and they, you know, if you're not capable of doing that, when the average home inspector goes in and finds persistent slow drainage, evidence of previous backups, chronic sewer gas odors, age of material concern, for me, if the house is on cast iron, it's probably old at this point in time. And I will tell people that they should have that shoreline scoped all the way out to the street to make sure they know what condition it's in. And actually, I'm also doing that with older houses that have plastic pipe, because they can sag and split and come apart as well. So we're gonna, how many minutes do we have? We're a little bit over.
We're a little over. So do you want me to go through these?
Yeah, if you want.
Yep. Common defects in report writing. Typical issues to report: high static pressure. You know, you're going to know if this exceeds the code maximum. Stress on fixtures. Improper or missing pressure relief valves. Poor functional flow you're going to report on. Slower backed up drains. So sample report narratives. High pressure without a pressure relief valve. High water pressure observed at the main supply, approximately 90 psi, measured at the exterior hose bib. This condition exceeds the maximum 80 psi specified in plumbing codes and can stress the plumbing fixtures, connections, appliance components. Pressure reducing valves, installation and adjustment by a licensed plumber is recommended to protect the system components and extend their service life. A failed pressure relief valve. You're going to write that up. Pressure reducing valve is present in the main water supply, but appears to be inoperative. Static pressure measured 95, substantially above the typical 50 to 60 output of a functioning pressure relief valve. And you're going to recommend replacement by a licensed plumber. And then low pressure, you're going to write that the below normal water pressure reserved throughout the home. Static pressure measure 35 psi at exterior hose bib. Upper level fixtures exhibited particularly weak flow. And again, we're going to make a recommendation by a licensed plumber. So here's some more support narratives about corroded galvanized pipe. Again, you're going to note that out. You're going to do an observation, a recommendation by a licensed plumber. Slow drainage. You're going to note where it's at. Basin empties slowly and draining procedure gurgling sounds. Try to articulate as much as you're hearing and seeing. Multiple drainage problems. Several fixtures exhibited slow drainage, including master bathroom sink, tub, and second floor. This pattern suggests common branch line restrictions or the main line blockage rather than individual fixture problems. And again, one of the things in your reports, just don't recommend a plumber, recommend a licensed plumber. And distinguishing observations from diagnosis, what inspectors should report on, which we talked about: high pressure, slow drainage, galvanized piping, flow reduces significantly with 12 flushes during operation, all the stuff we talked about. And what exceeds inspector scope: main sewer line has root intrusion at 43 feet, requires a camera. Like, Stan touched on it. If you don't do it a million times a day, you don't want to touch that. Because I've been in inspections where they've hired those people to come in, and it can be a nightmare getting the cap off, getting it on. They're constantly running back to Home Depot. So here, kitchen drain has grease blockage and pleat-trap beyond visual. You can only report what you can see. So here's some more things. Vent pipe has 2-inch gap at 6-foot height and ceiling wall cavity. It's not visible. So you only can report on what you can see and observe. All right, that puts us at the end. This is our logo, which is on our site. If you're new to us, if you go to our site where it says logo downloads, it is password protected. The password is Cornerstone, and you can copy and paste this or drag it to your desktop and then put it on your website or your marketing materials or whatever you want to do. You will get your certificates tomorrow morning. If you don't get them by noon, 1 o'clock, just email us or check your spam folder or junk folder. Sometimes they'll end up in there. Tomorrow, we have an in-person event in Cromwell, Connecticut, presented by NTEC. It'll be high efficiency heating systems and water heaters. That starts at 7. It's 2 hours, 7 to 9. So you'll get 2 credits. It's free of charge. Any home inspector is welcome to come if they want. You can register on our site. Walk-ins are also encouraged. If you forget to register, just show up. But the information of where it's at, what time it's at, it's on our website under in-person events. And I want to thank Stan for presenting tonight. We have a newsletter that we've been publishing for a year now. So if you're not getting the emails, you can go to our site under newsletters. We just published March's newsletter today. So you want to read that. That's got a lot of interesting information on it. Pictures about what we're finding, and then code. We have our if something's out of defective, we have that section of the report of the newsletter, and then local news and national news. So it's all in there, and it's an interesting read. So you can download that anytime. So thanks, guys, for coming, and you can always check out our calendar of events.
All right.